Hello friends, today we will be seeing the questions based on consistency and inconsistency of system of linear equations. So first question is 2x plus 5y equals to 17 and 5x plus 3y equals to 14. They can be written as 2x plus 5y minus 17 equals to 0 or 5x plus 3y minus 14 equals to 0. Always we need to write the equation in the form of ax plus by plus c. That is why I have written these equations like this. Now a1 equals to b1 equals 5 and c1 equals minus 17. a2 equals 5, b2 equals 3 and c2 equals minus 14. Now we are going to write a1 upon a2 is 2 by 5 and b1 upon b2 is 5 upon 3. Clearly a1 upon a2 not equal to b1 upon b2. So the given system of linear equation has a unique solution and the system of equation is said to be consistent. So they are going to intersect each other. So the given equations can be solved either by substitution method or elimination method to get the value of x and y. In second question, find the value of k for which the system of equations kx plus 2y minus 3 equals 0 and 3x plus 6y minus 10 equals to 0 has a unique solution. Here for a unique solution, a1 upon a2 should not be equal to b1 upon b2. Now we can see here a1 is k and here a2 is 3. So a1 upon a2 k by 3 equals not equals to b1 upon b2, that is 2 upon 6. So 2 upon 6. Now k should not be equals to 2 upon 6 multiplied 3 and k should not be equals to 1. Therefore, the given system of linear equations has a unique solution for all values of k except at k equal to 1. Show that here k should not be equals to 1. Show that the system of equations 4x plus 6y equals to 7 and 12x plus 18y equals to 21 has infinitely many solutions. The given equation can be written as 4x plus 6y minus 7 equals 0. That is a1 equals to 4, b1 equals to 6 and c1 equals to minus 7. 12x plus 18y minus 21 equals to 0. That is a2 equals to 12, b2 equals to 18 and c2 equals to minus 21. By comparison, a1 upon a2 equals to 4 upon 12 equals to 1 upon 3. b1 upon b2 equals 6 upon 18 equals to 1 by 3. And c1 upon c2 equals to minus 7 by minus 21 equals to 1 upon 3. We can see that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Hence the given system of equations have infinitely many solutions. In question number 4, find the value of k for which the given system of equations has infinitely many solutions. Now the equations are kx plus 3y equals k minus 3 and 12x plus ky equals to k. This becomes kx plus 3y. Bringing this on the left side, it becomes minus bracket k minus 3 equals 0 and 12x plus ky minus k equals 0. For infinitely many solutions, a1 upon a2 equals b1 upon b2 equals c1 upon c2. So here we are going to compare first of all a1 upon a2 with b1 upon b2, and then we will compare b1 upon b2 equals to c1 upon c2. On comparing a1 upon a2 with b1 upon b2, we get k square equals to 36 or k equals to plus minus 6. On comparing b with c, 3 by k equals to minus k minus 3 upon minus k or 3 upon k equals k minus 3 upon k. On cross multiplication, we get 3k equals k square minus 3k or 0 equals to k square minus 6k. Taking out k common here, 0 equals to k into k minus 6 or k equals to 0 and k equals to 6. Now we can see from equation number 1 and equation number 2, the common value of k is 6. So k equals to 6 for infinitely many solutions. Now show question number 5. Show that the system of equations 3x minus 5y equals to 7 and 6x minus 10y equals to 3 has no solution. This can be written as 3x minus 5y minus 7 equals to 0, and 6x minus 10y minus 3 equals to 0. So here a1 equals to 3, b1 equals to minus 5, and c1 equals to minus 7. a2 equals to 6, b2 equals to minus 10, c2 equals to minus 3. On comparison, a1 upon a2 equals to 3 by 6 equals to 1 upon 2. b1 upon b2 equals to minus 5 by minus 10 equals to 1 upon 2. And c1 upon c2 is equal to minus 7 by minus 3 equals to 7 upon 3. Therefore, a1 upon a2 becomes equals to b1 upon b2 but not equals to c1 upon c2. Therefore, the given system of linear equations has no solution. Let's come to question number 6. Find the value of k for which the system of equations x plus 2y equals to 5 and 3x plus ky minus 15 has no solution. Bringing all the numbers on one side, x plus 2y minus 5 equals to 0 and 3x plus ky minus 15 equals to 0, we get a1 equals to 1, b1 equals to 2, c1 equals to minus 5, and a2 equals to 3, b2 equals to k, and c2 equals to minus 15. On comparison, a1 upon a2 equals 1 upon 3, b1 upon b2 equals 2 upon k, c1 upon c2 equals to minus 5 by minus 15 equals to 1 upon 3. For no solution, we have the condition a1 upon a2 equals b1 upon b2 but not equals c1 upon c2. So we are going to compare first a1 upon a2 equals to b1 upon b2. 1 upon 3 equals 2 upon k. This implies k equals to 6. Now comparing b1 upon b2 with c1 upon c2, 2 upon k should not be equals to 1 upon 3. This implies k should not be equals to 6. So if we put k equals to 6 in equation 1, this is the equation 1. If I put here k equals to 6, I will get 2 upon 6 is 1 by 3. So we get infinitely many solutions because all becomes 1 by 3, 1 by 3, 1 by 3. That is a1 upon a2 equals b1 upon b2 equals to c1 upon c2. In that case, we will get infinitely many solutions if k equals to 6. And if any other values of k except 6, because it also says k should not be 6, then a1 upon a2 not equal to b1 upon b2. So we will get unique solution. Therefore, there is no value of k for which the given system of equations has no solution. Find the value of k. This is the next question. Find the value of k for which this question is 6, 7 number, for which the system of equation kx minus y equals to 2 and 6x minus 2y equals to 3 has a unique solution, b no solution, and c is there any value of k for which the given equations have infinitely many solutions. Now bringing all the numbers on one side, kx minus y minus 2 equals to 0, 6x minus 2y minus 3 equals to 0, a1 equals to k, b1 equals to minus 1 and c1 equals to minus 2, a2 equals to 6, b2 equals to minus 2 and c2 equals to minus 3. On comparison, we get a1 upon a2 equals to k by 6, b1 upon b2 equals to minus 1 by minus 2 equals 1 upon 2, and c1 upon c2 equals to minus 2 by minus 3 equals 2 by 3. For unique solution, we have a1 upon a2 not equal to b1 upon b2. This implies k upon 6 not equal to 1 by 2, or k not equal to 6 by 2, or k not equal to 3. So the given system of equation has a unique solution when k not equal to 3. For no solution, we have a1 upon a2 equals b1 upon b2 but not equals to c1 upon c2. So first of all, we are going to compare a1 upon a2 equals to b1 upon b2. Here we get k equals to 3, and when we compare a1 upon a2 with c1 upon c2, we get k not equal to 4. So here k equals 3 but k not equals to 4. Therefore, the given system of equation has no solution when k equals to 3. For infinitely many solutions, a1 upon a2 equals b1 upon b2 equals c1 upon c2. Again on comparison, a1 upon a2 equals b1 upon b2 equals to c1 upon c2. First we will compare a1 upon a2 with b1 upon b2. We will get k by 6 equals 1 by 2 or k equals to 3. And again on comparing a1 upon a2 with c1 upon c2, we get k equals to 2. So the value of k equals to 3 and k equals to 2 simultaneously is impossible. So there is no value of k for which the given system of equations has infinitely many solutions. Thank you.